Today we're going to look at the graph of the cosine and sine function. First, just a little recap. I would like to remind you some properties of cosine. So let's pretend this is a right triangle that is taken from a portion of the unit circle where the initial side is on my x-axis and the terminal side is after some angle theta. I remind you that because this is the unit circle, my radius is 1. Today we're going to talk about cosine theta. And just as a reminder, the cosine theta is the adjacent side over hypotenuse. Well, using this triangle as an illustration, the adjacent side would represent the x value of this triangle. So cosine theta, the adjacent side is the x value over the hypotenuse, which since this is a unit circle, the hypotenuse would be 1. So cosine theta equals x over 1, which can be simplified to x. This x value represents the x coordinate in an ordered pair. Cosine theta represents the x coordinate of the ordered pair. Now let's take a look at sine theta. Just as a reminder, sine theta is the opposite side over the hypotenuse, and the opposite of theta is this side, the vertical side. And the vertical side, my vertical distance, represents some y value, some y distance. So sine theta equals y over the hypotenuse of 1. And again, anything divided by 1 is itself. So sine theta equals y. So in the context of the unit circle, we're just going to take a look at the first quadrant for right now. In this context, I just discovered that with my ordered pairs, the x value is actually the cosine of that theta, that angle measure, whether it's in radians or degrees, and the y value is equivalent to sine theta. So for example, if I wanted the cosine of 30 degrees, so cosine of 30 degrees, cosine is going to represent the x value of the ordered pair. So cosine theta equals the square roots of 3 over 2. I could also say sine of 30 degrees equals 1/2. Now this is something you can easily check using your graphing calculator, or if you want to go to Desmos.com, just make sure you are in degree mode. So taking a look at Desmos, I do want to remind you that there is a tool or a way to change whether you are in degree mode or radian mode, and it's the little wrench in the upper right-hand corner. So if you click on that wrench, you can see here right now it is green in radians. We want to click over so that the degrees are green, and that will put it in degree mode. So we're just going to take a look real quick at, we discussed before that cosine of 30 degrees was equal to this number. We had said before it was actually the square root. Let's see if I can get this working right. The square root of 3 over 2. As you can see, those are equivalent numbers. So the cosine of 30 degrees is in fact equal to square roots of 3 over 2. And we can check this probably a lot easier with sine, because the sine of 30 degrees is 1/2, or 0.5. Now, I would also like to introduce you to the menu. We see the keyboard menu here that has all of the numbers and the squares and the X's and Y's and things that we can do. On the right-hand side, you see the word function, and it will give you all of these things. Here we see the trig menu, and it's got sine, cosine, tangent, cosecant, secant, and cotangent, all 6 of the trigonometric functions that we have talked about. We're going to get into the inverses of these functions also. Remember, that's how we separate a trig function from the angle. So if we want to identify the angle measure, we would use the inverse. And just as a really quick review, let's talk about that real quick. So if I had sine theta equals 1/2, I need to separate the sine from its theta, so I would take the inverse. So theta equals sine inverse of 1/2. Now if I were to type that, sine inverse 1/2, if I were to type that into my Desmos here, I could take sine inverse of 1/2, close parenthesis, around the whole thing, and it says it equals 30. That is 30 degrees. Watch what happens when I change this to radian measure. So when I change it to radian measure, notice that sine of 30 is no longer 0.5 like we thought it was, and the sine inverse of 1/2 is no longer 30 like we thought it was. So we've got to make sure that we are in that degree mode when we are looking for degrees. And you're in radian mode when we're looking for radians. We're going to discuss that a little more in pre-calculus, but that is not for today. Something that is for today is an interactive graphing activity that I found. And this is going to be a great visualization for the graph of sine and cosine. We're going to start with cosine. And remember, cosine are the collection of x values as it relates to the unit circle. So on the left-hand side, I have a unit circle. And what we're going to do is we're going to watch what happens as the orange dot goes around the unit circle. Watch what happens on the right-hand side. I'm going to let this keep going. So we're looking at the x values as it relates. So as the orange dot is going around, here we're in the first quadrant, my x's are positive, then we go into the second quadrant, they're negative. Third quadrant, x's are negative. Fourth quadrant, x's are positive. So if you notice, we almost have this wave that appears on the right-hand side. And if I were to keep going, that wave is going to keep going. Also, one key important feature to notice about the cosine graph is it starts at 1 because at 0 degrees or 360 degrees, my x value is 1. Now we're going to take a look at the sine function. This graph is going to be in red on the right-hand side, but we're still going to follow the orange dot around the unit circle. Remember that sine represents the y value. So let's take a look at what this graph looks like as it relates to the y values on the unit circle. So here my y values are all positive, and then after 180 degrees, my y values become negative. We still have the same type of graph. It still looks very similar to the cosine graph. It looks like a wave. But notice that sine starts at 0 because the y value of 0 degrees is 0. And if we were to continue after 360 degrees, the wave would keep going. Okay, it's just going to keep going and going and going. Let's take a look at both of them at the same time. This will be fun. We're going to go back to, refresh. Kind of looks like a double helix if anybody has taken biology or something to look forward to when you take biology. Looks a little bit like a double helix. Not quite, but it's just fun to make that connection between math and science. So once again, this is the sine, the basic one rotation from 0 to 2 pi of cosine. Please make sure you put this nice and big in your notebook. And then the sine graph, nice and big. I would like to point out something pretty interesting about both sine and cosine. The maximum of both sine and cosine is 1, and the minimum of sine and cosine is -1. Tomorrow we're going to talk about some other pieces of information as it regards to the sine and cosine graph. But as for today, I just wanted to do a brief introduction on the graphs of sine and cosine.